All right, again, this is a rational function. It's called a rational function because it's a. I got a box of pencils over there. Rational function is a function with a fraction in the numerator. A fraction. Now, what can't happen in a fraction? Can't have a zero on the denominator, right? So that would make something undefined if we had zero on the bottom. There's certain numbers that would cause a zero to happen on the bottom. Discontinuities. You can have what we call an asymptote, which is the graphs are kind of going in two different directions. Not quite. There are holes as well, which again, your calculator will not show it unless you. Not there. But it'll just be like a hole in it. Also, it's not shown on your calculator. It's usually about the only piece that y'all will see in pre-cal. There is another one, but that deals with cusps and stuff like that, and that's a different type of function that you deal with. So the big thing here is you don't have to graph it in your calculator. The graph is provided for you. You just need to read the graph. So we see there's a dotted line at x equals 3. The vertical line is in x equals equation. Do y'all agree? All right, so there's a is asking is what is on the left side of the 3 tapping on the right side of the 3. And the way they ask that, we're on question 9. Yes. These little negative symbols right here, that means the left, and this little positive symbol, that means the right. So what this question is asking is, what is happening to the graph on the 3 on the left side of 3? What's the graph on the left side? It's going negatively down. Right, that is negative infinity. Left side down toward negative infinity. That's all it's asking. So what is happening on the right? It's going up, so that would be a positive infinity. And that's it. That's all it's asking. Go ahead. It is. Okay, but the left side of the line. So right. Left side of the line is. Oh, let me ask you this question. When I say graph, what do you look at? Oh, very good. Okay. When I say graph, I mean the blue lines, what's being graphed on the coordinate plane. So the squares would be the coordinate plane. The graph itself is the blue lines. So when I say the left side of 3, we're referring to the graph doing the left. I don't care what the graph's doing going left on its own. That's not what the question's asking. The question's asking, what's it doing on the left side of 3? So if here's 3, the left side, blue graph on the left side of 3, looking at it, all right, what negative infinity. But now left itself. And then the answer here would then be about 1. So the answer there is 1. Because what you can see is there's actually an imaginary dotted line right here as well. But when I write it like this, x approaches a number, and then I either set the left or right side, straight to that. location. It is a capital sigma. It represents the sum of. So you're going to be taking the sum of a series, but instead of me saying, hey, go add 1, 3, 5, 7, 9, 11, I'm saying, here's an equation, which my credit class do or my online pre-calc class. They have to go find the number and add them up. I'm going to make you do this using a calculator. So this way, use a calculator. The book, okay, you hit that. You'll see the there. See it right there? Next to the 9 squared matrix. If you just hit that, that little sigma thing will appear. Mine's a little thicker than y'all's. That's just if you want to know what's mathematically, I'm plugging in each of the equations. So I'd get 10. That'd be the first. Plug in 4, so that'd be 13. I'd plug in 5, that would be 16. I would then add those three numbers and that'd be 39. Right? So each is like three numbers, but in calculus, typically you go from k equals 1 to like 100. Right? You don't want to be adding 100 different, finding 100 numbers and then adding those. You can just plug it. Not 100. I just do like up to 5 or less. It gets to that point, pull it up. That's the cap, and the draw bottom is where you can plug in one. Typically, it'll be 1 to represent the first sequence, but some people put 0 to represent the thing concept. Yeah, you can have the calculator, you just can't have. So as you're taking, study them, review them, look at them, because it could be easy right now. But if you don't ever go back and look at it when you come to Tuesday, and go, oh, I forgot what button to hit, and now I have to say, sorry, I cannot help you with that. It's just like a STAR test. So make sure you review. Again, all you have to do I don't think y'all really deal with divergence. Well, actually, y'all do deal with convergent divergence. We'll get to diverges away from numbers. So like infinity converges to a specific number. Like this one converges. It stops. All right, this next part, again, I can teach you exactly how to graph a piecewise function. We have a calculus. Let me teach you how to do that as well. So what you're going to do is yeah, I think that worked. have a sign. If you can remember that, I'm so a piecewise function goes left to right, left graph, right graph. And if I would three, then that top one would be left, the middle one would be the middle graph, and the bottom one would be the right, and it keeps going that way. So left. Just graph to the right. I can't go backwards. We always graph from left to right. Yeah. Well, no. There, so if the score is negative, it's a only side. Literally graphing, and you literally pick a pixel and jump to a different part of it. I didn't name it. Literally, what's called. Mhm. Say that one more time for me, then. Okay. Okay. Remember, to be a function of line, x can't repeat. So that's the path to vertical line test. So those x less two, those discontinuities will relatively be the same. They'll like stack on each other. So two and two. If I give you another one, the middle one would go from two to three, and then the last one would be three or something like that. You won't have an equation that will go possible because it wouldn't be a function. Something like this. Absolute value function is the very first type of piecewise function you're actually dealing with, where it's when x is greater or less than zero, it's going to be negative greater than zero, positive x. Well, the second one's the step function. Well, I teach it all the time. It's always left to right. We graph and we do math just like we read a book. Now, other countries might go right to left, but we do left to right. Mm-hmm. As write the notation for piecewise, it has to go left to right. So the top equation has to be the left side of the graph of wherever the breaking number is, and the second equation has to be the right side of that. Any questions? Again, algebra 2, but we got into this in module 5. There was another logarithmic module there. I don't know if I remember that. Stress about that when it's all, you could technically just type these. blue or yellow?
All right, so you're going to look at the grade. Does anyone see the word log? So
And then hit that log. Notice on the bottom. No, leave it blank. It'll naturally build a 10 for you. It's a base 10. So type 12, it gives me an answer. If I then type all of those answer choices, I'm looking to see which one gives me the same decimal. So in this case, that would be log 3 plus log 4. And I see that that would be my answer. Right? Now, the way they did that is what's 3 times 4? 12. So what they did is they expanded 12 and said X is 3 and Y was 4. Because then 3 times 4 would give you the 12. So that's what they did here. So if you can recognize or remember this rule and then recognize any other questions there? With which equation? The X equation. Very good. So I'm going to take the X equation. I'm going to get T alone. How do I get T alone? -1. Very good. That gives me X minus 1 equals 3T. What would you do next? Divide by 3. So I get X minus 1 over 3 equals T. What do I do now in step 2? Good. Just plug it into the T in the Y equation. So this becomes Y equals -2 times X minus 1 over 3 plus 4. Your job now is just to simplify correctly so you can drag and drop the correct numbers. So if I'm actually going to rewrite this as 1/3 X minus 1/3. Are you okay with that? I basically do the 3 and I divide it to the X, but there's like an imaginary 1 there, so that becomes 1/3 X. And then I take the 3 and divide it by the 1 to make it this. The only reason I did this, because when I distribute the -2, it's going to be a little bit easier to do the math. Yeah. So whatever the denominator is, you can separate each term on the numerator by that denominator. As long as it's one term in the denominator. I guess you do it to multiple, but you can't separate the denominator. So I do that so I can distribute here. That would give me what's -2 times 1/3? -2/3. -2 times -1/3? Positive. So at least I got the answer so far. Again, at this point, you can type this stuff into the calculator if you do struggle with multiplying fractions of whole numbers, or you just struggle with adding fractions and whole numbers. But does anyone happen to know what 4 plus 2/3 is? All you have to do is 4 into a third, so that would be over 3. 12, 14 over 3. 12 plus 2, that's all the 3. So 4 is the same thing as 12 over 3, and then you would add 12 plus 2. Yeah. Any questions there? So this is something you should know how to do. We did this in the last few lessons on the parametric equations. All right. You literally were tested over the last test, I think, or 2 tests ago. What would make this symmetric? So does the x-axis make this graph symmetric? No. X-axis is located right here. I even cut the graph in half. Does the y-axis make this graph symmetric? Absolutely. Literally that directly in half. The options were this question, cut it in half. It's the last, makes it that's in half. Any questions on that? And one of those is just a fact question. Number 15, if we would have got to module 4, I would have shown you all the tricks of the trade of trigonometry. You should have seen a lot of this, though, in geometry, but I do understand our geometry background. So let me kind of remind you, these are also ACT questions. You might have seen this. This right here, in triangle ABC is shown below. It tells you A, the opposite of big A, so that's going to be 8. Little c is opposite of big C, so that's 12. Big B is 35. So this is the information it gave. It's wanting to know what this guy is. I don't know if you learned it in trigonometry. I mean, in general, you should have learned it here. And this is going to be called the law of cosine. It works like this. A squared is equal to b squared plus c squared minus 2b. There's actually 3 equations for law of cosine. I'll show you how I just memorized that. All you have to do to find a missing side is take the 2 sides given, square them and find their sum, minus 2 times their product, times the cosine of the angle. So if you don't have to necessarily remember where's A and where's B and where's C go, but if you can remember that you're squaring the 2 numbers, so this would be 12 squared, 8 squared, minus 2 times their product, so it'd be 2 times 12 times 8. Cosine. Here's the kicker to this. That's what A squared is. All you have to do is put a square root over all of that and type it straight into your calculator. So make flashcards, study things like that. So when you see it again, you're able to read memory. But I'll show you how you can type that in your calculator. I'm just going to do a control x squared to make a square root, and I'm just going to type it. Law of cosine and law of sines are one of the 2 famous laws that you would use to solve triangles when it's not a 90-degree triangle. If it's a 90-degree triangle, the one thing you're supposed to learn in geometry is what will I use? No. If it's a 90-degree angle, what's the famous little acronym thing? No. Some people call them an Indian, but SOHCAHTOA. If it's a 90-degree triangle, you just use SOHCAHTOA, which was the main point of geometry, which was a sine equal opposite to hypotenuse, cosine's adjacent over hypotenuse, tangents opposite over adjacent. Doesn't matter how you label it, just depends on what angle you're looking for. When it's not a 90-degree angle, we have these things called law of cosines and law of sines. I will say law of sines are the easiest because it's just proportions, but you have to use law of cosine when you have an angle between 2 sides. Had I had if I'd known this side and this angle, I could have used a law of sine to find the rest of my answers. Go ahead. SOH, CAH, TOA. TOA. SOHCAHTOA. Usually, the two things that you'll remember from geometry is a squared plus b squared equals c squared and SOHCAHTOA. Do y'all remember what those do? Usually not, but those are the two things you remember. All right, number 16. It's just asking which ones are even and odd. There is a whole process of knowing if something's even and odd. I can literally plug in a value, see if I get the same function, see if I get the opposite sign. When dealing with polynomial functions, it's super easy. It's an even function. They're all even exponents. It's an odd function. If they're odd, if they're all if they are all odd functions. If they're a mixture of both, then it's neither. Case in point. What exponent's here? 1. So is 3 and 1 even or odd? Odd. So it's an odd function. 2. What exponent's here? 2 and 1. Are they both even or both odd? Neither. There's your answer. They either all have to be even or all have to be odd. Now, there is a kicker to that. Absolute value. When you plug in an absolute value, what is the answer always going to be? What other exponent does that? What always makes the positive other than absolute value? If I So anytime your answer is always going to be positive, it's actually treated as an even. So if you want to write that note down or somewhere, absolute value is treated as an even exponent. Okay? So therefore, if absolute value is even, what is 4? What's 4? Even. So that means that they're both even, so the function's even. If we look at the next one, I get 3, 2. What exponents there again? 1. So I get 3, 2, 1. Are they all even or all odd? Neither. I got 2 odds and an even, so it's a neither function. 99. What exponents there again? 99 and 1. Are they both even or both odd? They're both odd, so it's an odd function. That's all you got to look at. They either all have to be odd to be odd. They all have to be even, or if there's a mixture, then it's neither. There's more to it. But when dealing with polynomial functions, that's as straightforward as that can be. If this was other functions, it becomes a different ball game, and you have to plug in the value of negative x for all x's and see if you get the original function or all the signs change. So in this case, that's the easiest process I can go with. Any questions on that? Okay, so you can kind of almost use common sense on that. Talks about a finite arithmetic series. So now you have to build the equation for it. So I'll kind of walk you through how to do this. For starters, arithmetic series, you first learned about in Algebra 1. Then you were supposed to have seen it again in Algebra 2, and this would have been in our Modulus 5. This would have been the very last thing you would have seen in pre-calculus as well, when we talk about sequences and series of arithmetic and geometrics. Arithmetic, super easy, hopefully. It's A1 plus D times N plus 1. Just so you're aware, this is the first term. First term. This is the difference. That's the only thing you plug in. The N plus 1 stays the same. So when trying to build out equation here, first number you see is the 4. Since you're told it's arithmetic, that means it goes up by 4 every single time. So now you just like terms. What's 7 plus? And which one's the numbers? Common sense. You kind of know what this means, right? This is the top number. This is how many numbers I would add in the series. It says that there's 43 numbers in the series for 43. Realistically, do you think this is true? What's what number? 4. It's going up by 4s. Is there any way that 43 will be the 43rd number? No. So you can use common sense and say, well, that's not realistic. It must be 10. But I'll show you how to solve it just in case that's not the case. All I have to determine what number this is to go on top. I'm going to take the equation I just learned. This will tell me what that number ends up being. How do I solve for n? Check. What's 43 minus 3? It gives me. Sure. I'm not saying this is how it's going to be. It could have literally said 12 right there, right? But I want to make sure you understand how to get to the full process. This right here, again, should not be new to you. This is an Algebra 1 concept. All right. Then you see it again in Algebra 2. Yes, it's this in Algebra 2, we talk about 5 topics. It's in the second topic when you learn how to write y equals mx plus b. This is the first formula that you're given for arithmetic. Geometric comes into play when you talk about how to write an exponential equation. Any questions there? Okay. Seeing that y'all stopped at logarithms in Algebra 2, you might not have seen arithmetic in geometric sequence because that's typically taught at the end of Algebra 2. It's also typically at the end of pre-cal. An angle on its standard position with a measure of 4 pi what is it expressed in degrees? So this is the same kind of question as last time, but this time it gives us the radians. Yesterday, when we went from degrees to radians, you multiplied by pi over 180. So I told you to take the degree, divide it by 180, and then just add a pi to it. When you're going from radians to degree, you flip that. Pi. You can tap that straight to the calculator, and it pops out 240. I will leave this up here. Again, I do not know if it's going to give you one of these perfect numbers, but if you happen to look, 4 pi thirds is equal to what? 240. Don't depend on that, though. Yeah, you can actually type straight into the calculator, and it'll come out 240. No, that's not how that works. That'd be cool. Yeah, that'd be cool, though. No, that's not how it works. That gives you the angle for tangent. That's not necessarily the angle of itself. Yeah, go from degrees to radians, always pi over 180, and to go from radian to degree, it's always 180 over pi. That would have been the main focus in module 4 if we would have made it. But I think you do this in geometry about circle. I could tell you all about these trigonometric functions of cosine, sine, tangent, cotangent, secant, and cosecant. I could tell you how they graph. I could tell you how the inverses are looked at. It gives you these arc cosines and stuff like that. Or I could just tell you this is how you. So in your handy dandy calculator, You are asked to graph arc cosine. If you see the word arc, it just simply means inverse. So you can make note of this if you would like. But arc cosine simply just means cosine inverse. That's all arc means. Why they give it a new name, I have no idea. So if I want to know what the domain of this is, I'm going to simply just type this straight into my calculator as cosine inverse of x. So it's going to be trig cosine inverse. There's my x. I hit enter. There's my graph. If you want to see more of it, you could do menu. I like to do zoom, and I like to make it fit. There's my graph. However you want to do it. I like zoom fit. Looks really nice. I'm looking at domain and range. Or sorry, I'm looking at domain. My domain is what values? X. So if I do menu 5.1, and you don't have to do zoom fit if you don't want to. You can actually just do straight the menu 5.1. I just like to see what the graph looks like. I'm going to go over until I can't go over anymore. Does everyone see this dotted line? That means there's no graph there. So I'm going to go back until there's no more dotted line, which is about right there. What's that X value? The X value. Negative 0.9. If I scroll over to the other side until I see a dotted line, I come back. What's the X value there? So if I see that my domain goes from negative 0.9 to 0.9 from my calculator, which one of these could potentially be my answer? Okay. Are looking at it going, what type of halves? Go ahead and type in pi. The pi. Can that possibly be between -9 or negative 0.9 and 0.9? No, it's too big. Go ahead. Menu 5.1. Menu 5.1 is your friend when it comes to graphs. You can use that literally on every graph answer. And you're just tracing it, typing numbers in, things like that. All right. So now that I know my domain can't be pi halves, can it be 0 to pi? No, I literally went into the negative. So obviously it's more than that. So I can see that the only remaining answer must be negative 1 to 1. I saw that my graph only went to negative 0.9 and 0.9, but because of, I don't know, some pixels or something like that, I'm sure it goes a little bit further than that. Then probably goes to negative 1 to 1. Questions on how to find the domain of a graph? Type it in. You find one, see if the farthest x goes to the left and the right. And I just hit enter. You just got to remember that arc means cosine inverse. Yes, there's an X right there. All right. And I typed it and I just used menu 5.1 to see how far did my X go to the left, how far did it go to the right, which one of these could potentially be my answers. We good? All righty. All right, number 20 talks about the cognate section, which actually goes into play in module 4. Once you learn trigonometry, you learn about these cognates. You're supposed to learn this in algebra 2. It's a big topic in algebra 2, a very small topic in pre-cal. I actually skipped this when I took college. Because it's just not that big of a focus. But cognate sections basically are graphs that make circles, ovals, parabolas, and hyperbolas. Yeah, probably know what a circle is. Yes, you know what a ellipse is. Like an oval, basically like it's a circle that's been smushed a little bit. You know what a parabola is, right? Hyperbola is a sideways parabola. So instead of U shapes, you get like these guys. And the parabolas that you see in cognate sections are actually two parabolas on top of each other, or one going in two different directions. depending on what the focal point is. The main point of this is to know the equation. All right, so here you go. So let me talk. When you're talking about a hyperbola and you're given the center, vertices, and what we call the foci, basically these are just points in which they're symmetrical. So like, for instance, this is the foci, just to give you an idea. That's the foci. This point right here is going to be symmetrical, and then this is going to be symmetrical this way as well. This is a point they came up with. The objective in pre-cal is to learn how to graph these by hand, right? But we're not going to focus on that. We're just going to focus on the equation. So the equation here is x minus h squared over a squared, and then y minus k squared over b squared. This one. Part determining your a and b. H and k, if the center's at the origin, that. K. So if whatever the center is, that's your H. They're both zeros. That's why you only see X and Y squares there. What we have to determine now is the A and the B. To determine the A, you have to determine the major axis. The major axis is simply found root of your two vertices. So in this case, that would be 3 plus negative. Well, let me write out the formula first. This would be x1 minus x2 squared plus y1 minus y. You're dividing the difference. It's the distance formula is what you're. Zero minus zero is 0 squared is 36 plus 0 is. I wish that was the A. This value divided by 2. So 3. Your B I think it's just going to be the foci. We'll continue this process tomorrow, though. Three minus negative 3. Oh, I went a lot better than this because you already actually had the answers. My bad. On 34th, we'll come back into play. Yes. All right.